All right, welcome everyone. I hope you can hear me well. Yeah, today is the second day. We are doing our LeetCode. I wouldn't even say it's challenge, but it's just, yeah, we will do as much as we can. Hopefully we're gonna solve full top 100 like lists. Previous time we have solved 5 problems. 2 of them were completely stuck in some sense. So as I mentioned in my Telegram channel, that you should for sure go and subscribe right now, because this is there is a lot of important information going on there. So as I said before, yeah, previous time we have stuck with 2 problems. First one is in order traversal. So let's review them and resolve them. So recursive solution is trivial, of course. For in order traversal, it's extremely trivial solution. Oh yeah, for all new people, what we are doing here, last year I've been doing LeetCode streams as well, just to get my form back. 1 year has passed and we'll again are doing exactly same LeetCode streams. The purpose of it is just I'm casually solving the top 100 like list, and we see how it goes. We see you see how actually it can be done in real life, and that actually this big number of solved problems, it does not really help you that much, and it does not give you 100% confidence, and you still can fail quite a lot of problems with that. At least it is true for me. And yeah, and we will try to make an ideal problem solution that it should be on the interview, so you can see like how in general you should approach the LeetCode type of interview, and what should be the steps, the process, and kind of the ideal execution in some sense. And meanwhile, I'll be learning to deal with the stress while I'm solving the problem, because honestly, this is much harder when like, some number of people are watching you doing something, compared to, yeah, it's 1 a.m., you're alone in your room, and you're just solving the LeetCode daily challenge when no one sees you, right? So again, yeah, let's try to solve this thing again, and let's try to solve it iteratively that time. So let's briefly, I will show you the recursive solution, which should be pretty trivial one. So let's name it traverse, and if not, we just return, and we should, yeah, output should be just array, right? Yeah, nodes values. So this can be also named as answer, probably. So in order traversal, you can recall from last stream, you go as left as possible, and once you cannot go left anymore, you basically visit, or in our sense, you append, in our case, you append value to the answer, and then you go up stack, and then you visit the node that you got previously, and then you go to right. So the order is, first you visit the left node, then you visit the parent, then you visit whatever on the right tree. So it is expressed exactly the same way in the code. So you just first call your traverse recursive call for the left subtree, then you visit, in our sense, or in our case, it's just appending the node value, and then you do exactly the same for the right one. Node right. And then we should return answer. Probably this should be the trivial solution for yeah, of course. We should not forget to call it on our root, right? Exactly, that is the trivial solution, but now the problem is how to do it iteratively, because this is mentioned in the follow-up, and it makes it actually, in my opinion, medium problem at that point. Typical approach for turning something from recursive call to iterative, it really depends on the category of the problem, but general use case that you can do is that you actually you're actually trying to emulate the stack as a data structure. So instead of doing it natively via threads stack trace, via recursive call, you can have your own stack and try to emulate it with this stack that will be in memory in that case. So it will be on the heap, not on the threads stack. So it means you can fit much more elements and make it iterative actually. But it's not the case for in-order and post-order traversal, or no, sorry, post-order actually can be. The problematic one is, pre-order and in-order. So pre-order would be this one. Oh no. Yeah, pre-order will be easy for turning it to the heap stack or emulated stack. In-order is a bit harder, and this one is extremely hard. So post-order is extremely hard. But we are going to solve only in-order. So how do we do that? So let's try to, again, go through it and try to understand how our code behaves and try to emulate it actually with the Python essentially. So, oh my God. So, how we do that? So our in-order traversal works in which way? So we start with this node, we go as left as possible. Then when we don't have anything here, so these are going to be none, we actually visit node 4 and we go back through our recursive call because, yeah, we're gonna go here, append, and move out, and then we will be here again in the middle. So then we would check this parent node, and we go and traverse the right subtree, this line. And then here we again try to go as left as possible, go to 6. 6 again gonna have nuns as children. We visit it, then we go here 5. We visit 5, and then we go right subtree, and again these two are none, so we visit this again. So it will be 4, 2, 6, 5, 7. 4, 2, 6, 5, 7, exactly. So now how I can emulate it iteratively. So the trick here that, yeah, natural stack emulation does not work. We should just try to emulate the behavior itself. So the behavior itself is that we go as left as possible. We still want to remember whatever we have visited. And once we went left enough, we go upper, we visit whatever we have upper, and then we do same thing again with the right subtree. So this is exactly what we're gonna do. So we will have something called maybe node root, and while two things, we need our stack still because we need to remember whatever we're traversing. So if node is not none and stack, sorry, or stack is more than 0, so stack is not empty, what do we do? While node is not none, or we can actually do this, we go as left as possible while we are still saving every single node that we got. So stack append node not equals node left. Amazing. At some point we will go so deep to the bottom that we don't have a left child anymore. So in this case our node will become none, and we go out of this thing. And in that case, what we can do, we are popping just added node. So in this case, yeah, let me do this. So in this case, how it will look like in the mental model. So we start with 1, we add 1 to our stack, we add 2 to our stack, we add 4 to our stack, and now we are on the left node, which is none here. So we pop 4, and we add this 4 to answer. So 4 is added to answer, and then we will try to go to the left one, but to the right one. But the right one is also empty. So yeah, we will add pop node here. We will add answer append as a value. And then, yes, and then we would see node to the right. Yeah. And since node will be again empty, this will be fully skipped, this iteration. So then we will go just node, again, popping from the stack. So in this case, it will be 2. We will add 2 here. We will remove it from there as well. And then this piece of code would switch to the right sub-tree. And we again do the same. So it's pretty much we are emulating whatever was done with the recursive call. And after that, we return answer. And this should be pretty much it, I hope. Yes. Somehow, previous time, I wasn't able to emulate this. However, I did it many times, 1 year ago. Many times, 1 year ago, but whatever. Good, we've done this. Now the next thing that we were struggling yesterday is jump game 2. So jump game 2, oh sorry, I need to drop it because yeah, of course yesterday I was recalling every single piece and solving it in all possible ways because I was like really struggling. What was wrong with my approach, right? Like why it didn't work? In my opinion, I got even scared one moment because I was like, I had so big confidence that I should be able to solve it, right? But apparently with the pressure of people watching me or with some, I don't know, maybe I didn't sleep well or something like that, I wasn't able to do that. However, yeah, this problem is not very hard. Also, I've solved it many times, so yeah. So, let's try again today. What our problem statement is. So we have number of elements, and this particular element represents the maximum length of forward jump from index I we can do. Blah, blah, okay, and we need to return the minimum number of jumps to reach index n-1. So, and we are always able to reach that index. It's kind of guaranteed from the test cases. So how do we solve it? Again, as we mentioned yesterday, there are essentially 2 ways of solving that. 2 ways of solving that. First one is DP. Second one is greedy. So how we want to do this? Actually, we can start with DP, which can be a bit easier but slower. So how do we approach this problem as DP problem? So of course, let's assume there is no greedy solution, and our only solution, which is usually the intuition for DP, is to actually try out all possible ways of solving that problem. Which means that, let's say we are at index 0 right now, and we can jump here to the 3 or to 1. So we try all of them. And next time, whenever we are at index 1, we are trying out all possible jumps as well and see which one gives us the minimum number of jumps to reach out this index or anything here. So essentially, yeah, that is the kind of intuition for dynamic programming. Whenever we need to try out everything, and also whenever we see that we can get, let's say, to this point or to that point with so many previously done movements. So let's say to this guy, I can jump from 2, but also I can jump it from 1. And to this guy, I can jump from here to here, or I can jump from here to here. So you got the idea. There are so many ways to get to some sub-problem from where we would need to solve it so many times once again. And if this input is very long, of course, it will take so much time, so we want to memorize this. So whenever you see the pattern that you might get many different options to try out, and these many different options can end up in the same sub-problem, this is a dynamic programming most probably. So how do we solve it? For dynamic programming, you should define a nicely defined recursive function. So let's call it traverse or whatever. And how we can define our DP function? Let's say we can say that DP from the index I is equal to give us, or should give us, the minimum number of jumps from this particular index that are required to reach n-1 or anything further, right? So let's define this function. And how this function is going to work? Well, the base case, whenever we are somewhere here, we just return 0 because there are no jumps required. We are already in the end, right? But if we somewhere, I don't know, somewhere not here, what we are going to do, we are trying out all possible jumps, meanwhile recording the minimum one, so the jump that gives you the minimum number of moves later on. And then we just use it and return it as a minimum one from this subfunction, which will be used from this one or from this one, whatever it is. So how it should look like. First one is the base case. So if you index big is greater or equaling nums -1, we just return 0 because we are already at the destination. We don't have to do anything else. Next thing, again, we are trying to do to understand the most optimal way. So for that, we are trying out all possible jumps. So jump in range 1 nums index +1, because upper bound is exclusive in Python. So we're starting from 1 to this guy, and then sub result, let's name it that way. So before that, we want sub result to be something extremely big number, because we want to use minimum as our goal to find the minimum number of jumps. So for that thing, we're gonna call traverse for everything index plus jump. Yeah, and this thing should return us the minimum number of jumps that will be required from this index up to the end of the array, essentially. And then we kind of recording also, yeah, we should minimum jumps, which is going to be 0. And then what we are doing, if our sub result, let's name it candidate, if candidate is less than sub result, so sub result is going to be the most optimal out of all our options. It means we found something better. We found the way that will give us less jumps to use, so it brings us closer to the solution. So in that case, we are rewriting it. And also, we always want to keep minimum jumps as the minimum. So sorry, it shouldn't be minimum jumps. It probably should be the next index. Yeah, it should be the next index that we're gonna jump. Also, we should keep in mind the problem that I faced yesterday, that the next index that we want to jump, we always want to jump the farthest index possible. Why? I remember test case something like that we have faced yesterday. In this case, we can jump from 3 straight away. We don't want to go to 2. But going to 2 means we can jump further. We can jump to the length of the array index instead of length -1, which is this one. So for that case, we would try actually to maximize our next index, to jump as far as possible. Next index plus jump, because this is currently our next index. And I think we want to do it even for the same result. Yes. Or actually, we can even do this thing. Since we can jump always out of bound, for us, once we reached the last index of the array, we don't actually care how further we can jump out of that. We just need to reach the length -1 or further away. So for that thing, we would minimize this to nums -1. Yes. Wait a moment. So candidate is the number of no. This is not what we want. No, forget about this. Forget about this. I'm already confusing the greedy solution. So whatever. If candidate is less than sub-result, yes, this is what we should do. And in the end, we just return 1 because apparently we have to do some jump as we are not on the last index yet. And we are going to do our best sub-result, which is this, like the least number of jumps that we can actually do from all the next recursive calls. So for that sub-result, or let's maybe name minimum jumps. I think this will be much easier to understand. Yes, and in the end, we just return traverse 0. So let's try to test it out in our mind and try it out our debugging skills. So we're starting with 0, 1, 2, 3, 4. Initially we are at 0. So we try out minimum jumps infinite. So minimum jumps and next index infinite and next index is 0. Okay, so what we will try to do is we try to jump from 1. So first one we're gonna try to jump on first index. And since this is recursive call, in my mind I would straight away jump into this recursive call and try again from here. So on 1 we can have this guy. So from 1 we can jump to index 2, which is the first one. And again the same. And from index 2 we can again jump to index 3. That's why dynamic programming is extremely, how to say, exponential generally. So we're going to have a lot of these slope lines. So from index 3, we can again jump to index 4. And from index 4, we return 0. Make sense? Because index 4 will hit this thing. And then we go back and return from our traverse function as candidate equals to 0, this one. And in this case, it's number 3. We only can do one jump from 1 to 1. So we will return 0 plus 1. So it will be 0 plus 1. Yeah, so this is going to be 0. On the index 3, we're going to return 1 essentially. Yes, so it will be 1. And it will be, no, sorry, minimum will be 1. Minimum will be 0. Yes. So we will return 1. And next index is going to be, index plus jump is 4. This is when we jumped essentially. And here next index, on this second index, what will happen that from second index, Sorry, I missed the chat completely. Hello, have a nice stream. Thanks for content. Thank you, thank you. Hi, everyone. Sorry, I actually completely missed the chat, whatever. So at index 2, which is this one, we just jumped one ahead, and this is the only we can do because our maximum number of jump is 1 again. So the only thing that we are going to have is essentially minimum is going to be 1, but we are going to return 2 due to this guy. And next index is going to be 3. So this is what we have from index 2. Now back to index 1. Because from index 1, we also can jump to index 3 straight away, skipping index 2. So let's do that. And from index 3, we already know the answer, yeah, we can do recompensation again, but in real dynamic programming, we will cache it. So we know that index 3 will return 1, just 1. So having that in mind, we know that previously, if we jump to index 2, we had 2 jumps needed to reach the end. But if we jump straight away to this guy, we have only 1 jump. So for sure, our index 1 will choose probably to jump on index 3 for now. So what we're gonna do, that next index, the best next index is 3, and minimum is 1. All right, probably right, yes. The minimum is 1, and also what we can try as a last iteration here, we can try to jump 3 steps and go straight away to index 4. And index 4 is base case, which is 0. So in this case, our minimum can be even better, which is 0. Essentially, yes, 0. Which will leave us 0 plus 1, best 1. I mean, this line. So index 1 is the best case 1 plus 0, because this is the case, the furthest jump gives us essentially 0 jumps needed to solve the problem further. So this is what we choose. This is what will be here. And keep in mind, guys, that, no, actually it does not apply to us. It does not apply to us, yes. It's just good, it's amazing. It's amazing, yes. And now we come back to our index 2, which is, yeah, we started from 2, 1, yeah. So it should be this level. So from index 2, we are again, we kind of already calculated that as well. You can clearly see that, sorry, it's already calculated, blah, blah, blah. So we know the answer that for index 2, it's going to be minimum number of jumps required is 2. And from index 0, we kind of can make a decision choosing from stepping at index 1 or stepping at index 2. So stepping at index 1 will give us 1. Stepping at index 2 will give us 2. So we choose the minimum number of jumps, which is 1. So we are saying this 1. And we are kind of next index is going to be the last one, which is 1. And then this particular iteration in the end, it returns 1 plus 1. Since we have minimum 1, so it will leave us 2. So this is kind of the way it should work. It seems to me like it will work that way. So let's test. Wow, it even works. But in order to do this caching that I did just here, because you can clearly see that index 2 got calculated twice, index 3 got calculated twice, and stuff like that. So for that, we need to apply caching, and I allow Python. So this is how you do the caching. And now let's try to submit. Now it should work this time. Oh, we got somebody subscribed to Twitch. Thank you so much, folks. Thank you so much for following. Yeah, it actually works, but you see it's extremely slow because it's quadratic time right now. Because of the way that the nature DP is. I don't know, should I do a conversion from top down to bottom up, because we're gonna have a lot of DP in the end, so maybe we can just skip here as it's just yesterday's problem. Let's now try the greedy one. So this is kind of DP, it works, but we can do it in O(n) using greedy approach. So let's try a greedy approach. Let me get a sip of water. Some people are, 8 people are watching us. It's incredible results, but this is LeetCode, what can I expect? Amazing. So cool, let's try the greedy approach. So the greedy approach looks like that. Let me draw this again for you. So the greedy approach is the following. We always know that we want to jump as far as possible, since we know it is reachable. So we always want to give us as big space of choice as possible. What I mean by that is that from index 2, you can jump essentially from either to 1 or to 3, but the space of choice that it opens for us, depending on this, is quite different. So if we choose index 0, 1, 2. If we choose index 2, our space choice, space of choice is this one. So this is the furthest we can get, stepping at index 1 right now. However, if we step at index 3, we can get up to the last index. So it means, greedily, it's always more beneficial for us to choose index 3, because with choosing index 3, we have much bigger choice later on to greedily decide the best move for us, because we just have more options than this one. So it means we always want to go the option that leads us to furthest possible move. This is kind of the idea behind the greedy approach here. And last time I completely failed to do recursive call, which is essentially the same. We are going to do it per index. So let's say this recursive function should give us the number of jumps, the best, or in other case, the minimum number of jumps that are required to jump from index, this index essentially, to the end of the string. So again, we have exactly the same case. And again, we're going to try out all possible moves. But while we are trying all possible moves, we are choosing the best one. And we're returning the best one straight away. I mean, we are not trying them as in DP sense, that trying means we jump and then we recalculate all possible jumps up to the end. No. We need just to understand what is the further jump we can get jumping on next index. And this is the one we're going to go and be sure about that. So the best case is exactly the same. Once we reach the end, we don't have to do anything. Now, we need to track two things. What is the next best index to jump? And what is the further option we can get jumping on next index? So furthest is going to be 0, let's say, and next index is going to be 0, just the default value. And again, we start with the same sort of. Oh, we have some more comments. Hello, can you increase the font? Of course I can. Yeah, please let me know. It's not a problem, folks. Why LeetCode mostly use Python? Well, it's a good question. Let me answer it. So you see, it's kind of interesting. This is the languages I was using, essentially. So I started with my main, which was my C#. C# was my main language initially. And then I realized that it is extremely cumbersome, and it takes much longer to solve the problem, much longer to express your ideas. So I switched to JavaScript. It was much better. But Then I realized that JavaScript, as far as I remember, JavaScript didn't have enough functions that Python usually have, default ones. So Python, with its syntax sugar, it's the best language possible because you can very quickly code up your idea. And in terms of interview experience, when you have 45, 50 minutes, you always want to save your time. You never want to spend more time on something that you actually need to. So Python gives you much more kind of space to fail rather than C#. I know a friend who is solving everything in C++. He's a beast. I mean, he's doing code forces and stuff. He's doing that successfully, but for that you need to be an extremely clever guy to allow yourself to use C++, because if you go weird solution or wrong way, in order to rewrite it, I mean, in emergency case, you need to rewrite your solution or do completely different one. In Python, you'll do it 3 times faster than in C++, especially if you don't know like good blind typing and good speed of typing, you're kind of done. So Python is extremely good for LeetCode interviews because it saves your time, essentially. And it has a lot of extremely convenient functions that will save your time. This would be the answer. Andre, thank you for doing that. You're helping a lot. I'm a fellow software engineer and I want to ask you a lot of questions. So go for it. Go for it. You ask whatever you need. This is why we are streaming, right? Hendrik, you saw the results of today's contest. It's really sad that we have so many cheaters. Oh yes. This is actually one of the reasons I don't do contests. I did it 3 times, right, in my life. But it's so demotivating because nowadays probably most of the folks just do ChatGPT, Claude, Opus, whatever, and solve all the problems in first 5 minutes or something. And then also a lot of problems don't have real good patterns to learn. So they're a lot of problems are very unique problems that you will never memorize and never learn anything from them. So this is mostly, if you really enjoy it, you can do it, but I don't really enjoy algorithms, to be honest. I'm enjoying them from the perspective of interview skill, and that's it. I use Java. Yeah, Java is even more cumbersome than C#. I'm sorry for you. I mean, I mean that's okay. You can use whatever language you have, but you're just cutting your own time during the interview. I mean, you can do whatever you want, but yeah, it's only from the interview optimization perspective, Python is better. So that's it. What should be our first priority nowadays, system design or DSA? That's a good, depending on your position. So I know, for example, that Google is not doing system design before the senior role. So if you're applying anything below L5, you're going to do just LeetCode questions. And I know Google is not the only company that is doing that. So quite a lot of companies would not even give you a system design. So for lower levels, of course, it's DSA, 100%. For higher levels, if you target in senior plus, system design is much more important, I would say. System design is much more important. And behavioral, you have to have leadership things. Okay, so let me get back to our jump game and greedy solutions. So we are trying all possible jumps, and we try to get the furthest space of indexes we can reach, jump into the next index, and the furthest next index. So how does it look like? We're starting from 1 to nums index. I mean, I'm Indian, so you know the meme, most of India still uses Java, so DSA is that aspect is pretty useful for me. Yeah, but to me, it doesn't really make any difference. Usually you have the same data structure, same everything, so I don't know. It's just Java requires you much more typing. In my opinion, this is only my opinion, folks, keep in mind. So, during our jump, what we are going to do, our candidate, or our, potential candidate, and by candidate, I mean what exactly? I mean, this the furthest indices we can reach by jumping to the next index. So in our case, our candidates are going to be from index 0 is going to be for 3, it's going to be 4, for 1 is going to be this one. So this is going to be our candidate, which is index plus jump. And then if index plus jump is actually less than length nums, which means so our index plus jump is going to be exactly either number 3 or number 1, but also it does not limit our space, because our space now is calculated used the number of jumps we can do from that calculated index. So for that reason, if we still are in range of our array, because if, in case it's not 3 but 4, our space jump would be this one, and this is the empty one, so we cannot kind of calculate the next possible further index from this one, because this one just doesn't exist. We will get error, right? For that reason, we need this check, and we then increase in candidate to index plus, nums index plus jump. And now what we are doing, if we found that candidate is actually further than our furthest point so far, or equal to it. We need equal, because if we can get the equal furthest thing, but still we can get better index or further index, we want to get this further index. So next index is going to be maximum next index, or index plus jump. Yes, this is kind of our next jump, which is in this case these red arrows. And then furthest is going to be candidate. Then we return 1 plus recursive call to the next index. I guess this should be something that we need to do. So let's try to debug it in some sense. It should be a bit easier debugging than with DP, because DP is always slow to debug. So let's say, let me put the indices. Let's say that we are at index 0, and for 0 we have first 0, next is 0. So what we are going to try is, our jump is going to be from 1 to 2, and to make it to 2 we should do this. So jump would be from 1 to 2. And for this jump, we calculate candidate. Candidate is 0 plus 1. And since we are inbound, plus value on index 1, which is 3, which equals to 4. Which makes our further 4. And next index, index plus jump, which is 0 plus 1. Right? Right. Then we kind of will try out, let's say, next one, which is going to be 0 plus 2. And at index 2 we have value 1, so plus 1. It's going to be 3. We would not meet this criteria, so we will just skip, and that's it. So further away is 4, and next index is 1. So let's try from this. The next index is going to be 1. And yeah, we are returning 1 plus and whatever we will return here. Since our best next index is 1, further is 0, next best is 0. Now, we are jumping from 1 to 3. Exactly like here. So first our jump is going to be current index 1 plus 1 plus 1 plus 1 is going to be 2, and value under 2 is 1. It's going to be 3. Let's, because it's more, we are going to record it. 3, and next index is going to be 2. This part. Okay, next thing, what we going to calculate is going to be 1 plus 2, and at index 1 plus 2 equals 3. This guy is going to be 1 as a value, is going to be 4. 4 is further than 3, that's why we are overriding, and next index is going to be 3. And then the last one is 3, which is yeah, which is going to be 1 plus 3 as our last upper bound here. And under 3, we have 4, sorry, 1 plus 3, 4, and 4 index is 4, so it's going to be plus 4 equals 8. 8 is clearly more than 4, so we are rewriting everything here. And our next index is going to be 4. There is no more for loop jumps left. So what we are doing is essentially, yeah, we are going to jump our next index to 4. And 4 is base case, so we return 0. And here we return, here we return 1 plus 0, and here we return 1 plus 1 equals 2. So that should essentially work, probably. Let me check. Yes. Okay, guys, here we go. Let's spend our next 40 minutes for me being dumb. All right, output 2. Yeah, I think this is the case. This is exactly the case I was mentioning. So when we here, what are our further options? I will even show you. I see the messages, and I will read them in 1 second. So our first option. So let's say we're index 0. What is our option? We can jump to index 1, and our further, the furthest index possible would be 0 plus 1 plus 3 equal 4, and 4 is like 2 indices after the array, and this for sure will be the further. And we're going to compare it with what? We are going to compare it with plus 2 plus 1 equal 3. This emulates jumping from index 0 to index 2, and the space option is 1, so plus 1 equals 3. So we don't choose this option because actually jumping to 3 gives us more options, right? So we choose this one. But in this case, we are going to jump twice instead of just jumping to the end. So how do we fix that? And I think this is the fact I was missing yesterday. So we don't care about candidate being strictly further. We just need it to be bigger than furthest or equal to the length of nums minus 1. Because if we reached like the last index in our array, it is already enough for us to win in the next jump. It's kind of the best case scenario. So in this case, we still want to catch the further possible index. So this kind of should fix the situation, hopefully, and it does. So now let me, yeah, it works, and now it works much better. It works in, let me calculate. It's O(n) probably, as I understand, because we're gonna touch each index like at most couple of times. And now we're gonna convert it, of course, to iterative solution, which is the native one, to close my mental trauma from yesterday's stream completely. Okay, so what should be our first priority nowadays? I answered. I'm Indian, you know, they say, okay, Java. Yes, how do you actually approach LC problem you have done before that you can't right now? This is how I approach it. I failed miserably yesterday. I spent yesterday's evening on revising this problem fully and resolving it in all possible ways with DP, iterative, recursive, greedy, iterative, greedy, recursive. And now I just realized why was the problem. So if you want, yeah, let's actually check the yesterday's stream. It will be funny. It will be funny actually. What was the problem yesterday, why I couldn't solve it, and whether I'll be able to spot it now, right? It will be interesting. So if we go to yesterday's stream, this is the yesterday's stream. You probably should be able to see it. Yes. Yeah, so you see, I'm trying to think about it, and then, yeah, at some point, when did I first time submit it? This is what I'm interested in. Explanation, blah, 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 blah. It's pretty much similar approach, but the thing is I was missing this minimum. Okay, this is different. Yes, now exactly the same case I faced. And you see, yes, I was missing that that current reach, the maximum possible reach, should be not just maximum reach that we know so far, but it should be capped by minimum. By minimum capped with the length of the array. So let me show you exactly. So you see, this was our max reach in this case, and we should cap it with length nums minus 1. And I didn't do that. At some point, I even got some idea, I remember, about, I was kinda, but I didn't put minimum to the right place in some sense. So this was kinda the problem. This is how I approach it. I kinda redo it all possible ways and hope my mind will remember it. Bro, how to start the essay? I'm confused and equally overwhelmed by stacking in syntax and getting out the algorithm actually. Pick Python, start solving lists, do only one pattern a day. So once you hit some unknown pattern, stick with it for next 3-4 days and solve problems only related to this pattern. Then move on. This is it. There is no like easy way. In LeetCode, there is no easy way. Sorry, not for dumb people. There is easy way for LeetCode for clever people, but I'm not a clever person, so I cannot kinda help you with that. Let's switch this to iterative solution, because usually interviewer would say you like, sorry man, this is recursive, we can get Stack Overflow, blah blah blah, so let's do it iteratively. So iterative solution will be pretty same, but we're gonna keep our next index as variable. So we're gonna start with just index, which is going to be 0, as here. And we're gonna do exactly same thing, like here. Just copy paste. And what we are going to change here is that it's all good, but we want, instead of this, we would record, we should also see answer is 0, which is number of jumps. So here we should add one jump, as we did just here. And also, we want to change our index to next index. And then we return answer. Oh, no, it should be inside actually. No, sorry. What am I doing? It should be, we also should have this index less than length nums minus 1. Yeah, because that should be it. So we start with index equal to 0, and then we kinda iteratively trying to get the first possible index, still the same approach, same everything. And once we found the best index, we should jump. Our jumping, in a sense, is just rewriting our current index to something else and memoizing or counting the jump that we just did. That's it. It should probably work. Okay. Yeah, it works, as you can see. Now my yesterday's trauma is fully cured, so I'm very happy. Now I again feel like I'm able to do LeetCode. Thank you so much for attention. Let's jump to the next pattern. So how we approaching, we just do all easy and medium problems for topics, topic by topic. So we do one problem from topic at a time, and we will just round robin. Hashing to Zoom. Okay, let's go to Zoom, and before that I'm gonna check the chat as well because I seen some message. I start the essay, but somehow I keep coming back to list problem again. I'm struggling with consistency. Any suggestions on how I can stay focused and consistent with the essay? What do you mean by consistency? You mean you're just skipping the days of doing LeetCode? I mean, you should just want to get better in that. You should have good reason to keep progressing the LeetCode, and that's it. Without good reason, honestly, let me put it that way. I don't really believe in discipline, right? So yeah, this is my whole statement. All these coaches and all like these people, yeah, you should go discipline. Even if you don't want to do something, you should just overcome yourself and yeah, do the shit you need to do. I don't agree with that. I personally think this will not work. This will make you unhappy. And this will make your life worse. It will make your life better only if your main goal is to make yourself disciplined and you're gonna get enjoyment from overcoming yourself because you'll feel like you're improving your discipline as a skill. This is the only way how it can work. But if your goal is to get to be good at LeetCode and not to get more disciplined, then you will not enjoy overcoming yourself, and instead, so if you do it by overcoming yourself every single time, you won't, you will not be able to keep consistent solve, or how to say it. You will not be able to be consistent. This is kind of my resolution. So whenever I would try to push myself through the discipline, yeah, I have to do LeetCode without a good reason and desire, it will not work. For me, what helped me, I clearly realized that LeetCode is kind of interviewing skill. So if I want to get good offers, if I want to not be anxious about layoffs and facts that next day my boss or company can say, oh, sorry, we are layoffing, you have 2 months to find your job. And also I'm staying on visa, right? So like I literally can be kicked out from the country that I eventually found extremely good and pleasant for me, and I really hope I can stay here longer. This makes you kind of rethink, and this makes you like LeetCode even, in some sense. So I was enjoying solving the LeetCode because I know this is kind of my safety. This is my safety. I don't want to be anxious about losing the job. I want to get better offers. I want to get offers in big tech, right? So I have to keep this skill, otherwise I won't be able to get this. So your consistency really depends on the strength of your goal and desire of the outcome of solving LeetCode consistently. So if you don't really want to go big tech, or, I mean, you might think you actually want it, but essentially, somewhere deep inside you, your desire might not be strong enough. In this case, you lose consistency. So my idea about the motivation and discipline, that you just need to have very huge passion and desire to reach your goal in order to be consistent and actually want to do what you need to do. If you don't want to do, either you have depression or you don't really want to reach the goal you somehow believe you want to reach. This is kind of my opinion on that. So what helped to me? What helped me that, yeah, I knew I need to get an offer. I need to solve LeetCode. So I was solving the lists and stuff. Once I got the offer half a year ago, I kept doing that because I wanted this cap. So that's why streak is 300 something right now. Right now, I just want to get a hoodie from LeetCode, so I keep doing that. And I still want to keep my anxious about layoffs as least as possible. So that's why I'm doing LeetCode. This is my motivation. Okay, so let's solve that two-sum. which is first problem in LeetCode actually. I didn't solve it for a long time probably. Yes, 1 year ago. So you can array integers and integer target return indices, so two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So you probably remember, oh sorry, I just recall how it should be solved. So you use basic math principle. So if you have num1 plus num2 equals target, if you have fixed num1, you can find what num2 you need. So num1 minus target equals num2. It's easy math, right? Or it will be minus, right? Right, yes. Or otherwise, yeah, we can do differently. We can fix num2 and just make it so it looks better. So we can just pass the num2 here. And we can just fix num1. Whatever works. So the thing is, and the idea behind this problem, which is actually quite usually asked nowadays, but just with quite different follow-ups. So usually the pattern wouldn't be hashing. So how we can solve it? We can pre-compute how many or which, do we have unique numbers or no? Yes, so since we don't have unique numbers, or at least we don't have any mention of them, and do we need, no, we don't care actually, we don't care, so we can only have set. So we pre-compute all the numbers we have, and then using this math, we can just traverse and try out all possible num1 as, num2 as static one, and then just see which num1 we need to get given this num2, and this will be the number we need to get. And if this number is in this set, it means these two are the numbers we need to return. So first we need to kind of put it in our set. Then we need to traverse for, let's just stick with my ugly math formula. So we try to pin down number 1. So this is how I'm gonna do. In nums, our needed number will be target minus num2, and if needed in S, then we return num1, num2. Sorry, it's not needed, it's going to be num1. And just for default case, we can return -1, -1, whatever. What? How come? Okay, now let's debug. In my mind, I had some feeling that it would just work like that, but essentially we still need to debug it, right? So let's try to debug it. We put it into the set. Hopefully the set would, and Python would parse it right. So we try out every single num. So let's try it. So for us, we will have 2. And then target would be 9 minus 2, which is equal to 7. And it's sure, okay, we need index. Oh my God. So for that, we need then map. We need map, I'm sorry. I was returning the values instead of indices, I'm stupid. So map, let's just do this. Or default dict would be okay. Will it be okay? It will. Okay, and then some indices magic. Yeah, for readability, we can put even this one. Or even that one. Yeah, it's just problem with the mass. So we found the actual values that add up, but the problem was that we were returning the values, not the indices. What the hell? Yeah, okay, because it should be map. Oh my god. Oh yeah, we also cannot. Yeah, I'm sorry. Actually, this is I somehow underestimated the problem. So essentially, yeah, the problem is that we can get the same index as in this case, and this one we cannot use. So yeah, in this case we need to do something differently, which is we're gonna store all the indices that we have for this number, and then what we're going to check is that if number that we require is in map and our index, which is index, which one index, and our index 2 not in map number 1. So what we are checking is that our number that we just pinned, which is 3, which is index 0. We have 3 in the map, but the only index we have is 0. So if our pinned index in array of indices here, we kind of don't want to proceed. So we proceed only if these two are not equal, or yeah, rather we can. No, I'm not sure can there will be duplicates, because it will be much simpler to work not with list but with just with single index paired with number. So let me check this. If number is in MPS and our 0 it's not, it will be in map, so we don't proceed. The next one is going to be 2. We're going to search for 4. What about target being less? No, target should always be bigger because it's summing, right? What is your problem? Yeah, of course. Or rather, what we can do. Yeah, something like that. This all complexity is because they don't really mention can we have duplicates or no. Yeah, this is the reason behind the complexity. Because now we have to work with list of indices, which is quite unpleasant. Yeah, now it should work. But now I want to really check whether we can actually work with index instead of list. And yeah, should be int. Should be this one probably. Let's try it out. Let's see. It works, but what about other test cases? I'm just wondering, like on the interview, I would actually ask, like, do we actually need list? And it turns out we don't. It turns out that we cannot have duplicates, and it's not mentioned here. Yeah. So yeah. I mean, what else to say? You should clarify this on your interview because it would simplify your life so much. I think discipline is self-constructed thing to feel how ideally we should operate on our lab, but not every day is the same, so having a reason to become good at something can help. Well, yeah, but I don't really believe in discipline. I'm more believing into passion and desire. You need to add them up after if condition. Oh yeah, thanks you were helping me, guys. Thank you. Thank you. Don't pre-compute append as you go. Yes, we don't have to pre-compute. We don't have to pre-compute, but will it improve anything? So I know what you mean, that we can just do something like that. So this is our what? This is our index 2 num2, and for num1 we want target minus num2. And what you mean, probably, as I understood, that we want to check if num1 in map if num1 is in map, and map num1 is not equal to index 2, kind of return something like that. And otherwise, as we go, we are adding it here. So we are adding it num2 equals index 2. Is this what you mean? Let's try to check it. But I don't think it will improve complexity anyhow, because you would still, in the end, worst case, you will store everything in map, right? It can improve in some cases a bit, but overall, big O will stay the same. Let me check whether it will work. So num enumerate, yes, target minus num1. Okay, if in map and this is not equal, we return. Otherwise, probably should. Yeah. Hi mate, how is it going? It's going well. It's going well, thank you. I have a question I ask. Yeah, Fox, it's the stream. The purpose of the stream that we're casually solving LeetCode, and you can ask whatever you want, and we can chat about anything. So ask whatever you want. This is kind of your chance. Other place you can ask me in the Telegram chat that you should go to description and subscribe, for sure. Yep. So let's go to next problem. Let's go to next problem, which is heap. Oh, heap, I like heap. Heap and graphs. Kth element in an array. So given an array nums and an integer k, return k largest element in array. Note that it is k's largest element in the sorted order, not k distinct element. Okay, so we can have duplicates. Amazing. Yes, so essentially what we can do, we can just sort and return it by index, but I think actually sorting is better than using heap here, because heap would use additional space, and sorting, if it's quick sort, it will not, but still will be the same time complexity, I guess. So let's first try to, I don't know, solve it using just sorting. So how I can do it? Let's try this example. It's 1, 2, 3, 4, 5, 6. And with k's largest element, so second, this is the first, this is second. Do I get it right or no? Let's try this one. I just want to understand. 1, 2, 2, 3, 3, 4, 5, 5, 6. Right? Seems like. And what about indices? We don't care about indices. Sorry. And k equals 4, so first, second, third, fourth. Yes, I got it right. K should be less than length of indices. Yes. So essentially, first idea that comes to my mind is we can just sort and pick up the index. Yes. So if we are using quick sort over the input array, and we assume that input array is not counted as space, it can be done in O1 and this is space. And for time, as far as I remember, quick sort is not strict log n, it's amortized n log n, or so it's not worst case. In worst case, it can be quadratic essentially. But if we are using merge sort, which I don't know which Python is probably using something else completely. So yeah, let's first solve it trivially. So as on interview, you're gonna discuss, okay, I can solve it with sorting, or I can maybe try to solve it with heap. Now the question is, do we want a max heap or min heap? Probably we want, what do we want? What do we want? So we can keep its largest index. Okay, can't we go with min heap? And we can just go, and it will be size of k. And we can just go and essentially append it. And whenever we append it, and we see bigger value than currently is minimum 1, we pop minimum 1 and add biggest one. And in the end, we will just pop the last one. Yeah, so the idea is that I have currently in my mind. Let's try to run it. That we have min heap, or priority queue or whatever. In our case, it will be heap, I guess. And how we operate? We keep heap of size k. Whenever we run, we overflow our size. So let's say currently our size 2. Whenever we overflow, we pop the minimum element and we add wait a moment. Yeah, we kind of want to. The problem would be if we popped element which is bigger than current element. What will happen then? Okay, so question. I'm a college-going student and my friends gave me LeetCode for some time. Then I built my portfolio and I think I do good work, but things didn't go well between me and my friends, so I lost access. Okay. I was trying freelancing, but I was new in market, so I didn't know how to get clients. So now I know, but I don't have cloud account. So is there any other way, you know, how I can get LeetCode? Is it a joke? I don't know. Or is there any advice would you give me, like what should I do? By the way, would you like to review the website I made? It sounds strange, man. If you are successfully freelancing, buy yourself a cloud code. I think. I mean, if you're freelancing, probably you are making money out of it. If you don't have money out of it, I mean, yeah, find somebody who will give you to you or use free version. I think there should be, at least there was a free tier, like very cheap models, at least for Cursor 1 year ago. I remember that was the case. Yeah, and try to get into the job and making money. Freelance is not the right way. Probably if you're a new grad, you should get this opportunity and try to get internship. Yeah, $20 Codex or even $20 Claude, you can do a lot of stuff with it. Okay, can you solve it without sorting? Exactly. So let's think about it. So if we are using min heap, let's try to run it just for sake of example. So let's say we're gonna have 2 and 3, and now we face 1. 1 is less than minimum 1 in the heap. So we just skip them. We just skip it. And then, so 1 we just skip, then it's going to be 5. 5 is larger than minimum 1 on this heap, so we pop 2, add 5, and then we go to 6. 6 is bigger, or yeah, it's greater than 3, so we pop 3, put 6. 4 is less than 5, so we kind of don't care. And the current kind of top of the heap is the value we need. Let's run on this one. So we have 3, 2, 3, 1, right? And now we have 2. 2 is bigger than smallest thing here, so we put 2 here and pop 1 essentially. And we have 4. 4 is larger than these 2, so we put 4 here. 5 is larger than these 2, so we put 5 here. Another 5 is larger than random 3 here, so we put 5 here. And 6 is larger than this 3, so we put 6 here. And now our top of the heap is 4, and answer is 4. So exactly this is the solution we want to pursue. So let's just do straight away with the heap. So we're defining heap. We processing the num in nums. We are doing, yeah, if length of heap is larger than k, no, let me do this way. So first case, if our length of heap is less than k, it's simple case. We just do heap to heap push. Heap and pushing the number. That's it. Else, if we are overflown right now, what we're gonna do, I think this is our smallest number, which is under heap 0. So we are checking if current number is larger than our smallest number. So if number larger than our smallest number here, then we are doing heap pop, and heap q, heap push, heap num. So we're kind of removing the smallest in the heap and adding current one. If number is less than smallest one, we just skip it. And after that, we return heap 0. I think this should kind of emulate what we were doing before. So heap less than k. Okay, we are adding. Then if number bigger than heap, We are popping and adding. Yes, let's try it. Yeah, kind of works. Let's see. Yep, it works. Amazing. Nicely done. I mean, you're gonna tell me, is it nicely or not? Let's do linked list. Next one. So comments. Can you review the website? Oh, I think I answered that. I mean, I probably can, but I'm not sure. Is it? Yeah, you can share later on in private message. I can privately do that. I don't think we need to do that on stream. Oh, bro, has the mythical LeetCode hat? Yeah, I do. I do. I do. Hey, hello, AI viewers, Steambook. Okay, some ads. I don't know. Yeah, I'm too lazy to even remove it. Okay, whatever. If you need AI viewers, Steambook, like go for it. I don't care. Okay, so maybe this will be the last question today. I don't know how many we solved. Well, maybe one more. So add two numbers. Given two non-empty linked lists representing two non-negative integers, great. The digits are stored in reverse order. I remember this actually would help us. Each of their nodes contains a single digit. Add the two numbers and return the something. This okay. You may assume two numbers don't contain any leading zero except the number 0 itself. Amazing. So 3, 4, 2. 4, 6, 5. This makes our life easier because, yeah, if it would be original order, you know that actual addition is happening from the least digits to bigger digits. So we're gonna operate on hundreds in the last at last step, which is exactly the last node here, so it's kind of simplified. So general rule here is how do we do addition? The simplest case for addition is that we have sum less than 10. So if we have 3 plus 4 is equals 7, 7 less than 10, it's easy, we just write it down. But what happens if we have, I don't know, 5 plus 6 equals 11? What do we do in our addition? So in our addition, we should carry, in a sense. So if we have this case, we kind of remember that there should be one more dozen is the right word. So we're gonna remember that there was 10 that we should kind of remember for the next one. So here we would write 11, which is 10 minus 1. And we would remember that there was a single digit for dozens. And we need to write it down here as well. So tricky part here would be is to remember this carry and not forget about it, essentially. Yeah. So how should be our approach? So we probably will be creating our separate linked list as a response. We are not going to reuse anything here. So we're adding, if it's simple case, we just add a new node and proceed. But if we have case that we have more than 10, we are adding 10 minus whatever is, or, sorry, in this case, this should be the answer what we are adding here. This one should be 11 minus 10. And we remember the next carry. And whenever we have carry, non-zero carry, we adding it to sum, and then everything continues. I hope it makes sense. So we're starting with dummy node, which is going to be list node with nothing. Starting with this guy. Oh yes, we also, yeah, the problem here that what if we have kind of 2 243 and 46, how it would be represented then. This is a good case for that. Let me think. So we're kind of assuming this is this one, right? So in this case, response should be, or answer should be which one? So it's going to be 18, one we remember. It's going to be 19, one we remember. It's going to be 19, one we remember. It's going to be 19, one we remember. It's going to be 0, 1 we remember. It's going to be 0, 1 we remember. It's going to be 0, 1 we remember. It's going to be 1 in the end. What? Sorry, we are doing addition or? Sorry, I didn't get it. I need to return to school probably. Let me try again. Maybe better would be this one. So, how would I do that? 9 plus 9 is 8, right? And 1 we remember. 9 plus 9, 18. Plus 1, 19. We write 9 and 1 remember. Exactly same here. Exactly same here. It's going to be 10, so we remember 1. It's going to be 10, we remember 1. Why 8? Sorry, I'm stupid or what? Ah, okay, it's reversed. Oh my god. I'm stupid. Okay, sorry, it's right. It just should be reversed. Oh my god. I thought I got dumb or something. Current on 10 minus 1, next node carry 1. Yeah, sorry, it was just typo. It was just typo. Yeah, you're right. You're right. It was just typo. I mean, something what I'm writing and what I'm actually thinking are two different things. So, okay, we're gonna have, I don't know, let's do it, let's name it top, or we have L1 and L2 already. So while we have carry equals 0, while we have L1 or L2, at least one of them, ideally 2, we proceed. If not L1, and we should carry current sum, which is 0. If not L1, we definitely know the only single node we have is L2, so we do S plus equal, this should be the case, S plus equal value of L2. And if, or can we do differently? Maybe we can. So it covers more cases. If L1 or if L2, this can be the case, yes. So if we have L1, so top, we add in the value. If we have L2, we add in the value. Now if we have carry more than 0, we are adding value. And now, curious if you can share what is one time you have used linked lists at Microsoft. During my interview to Microsoft, or during my interview to Snowflake while I was at Microsoft. Outside of technical interview, like as a part of job. No, usually, generally, it will be less than 1% when you would actually implement or use something from algorithms. General understanding sometimes helps. What helped me really from LeetCode skill is be able to debug everything in mind without actually running service locally or debugging or whatever. Because Most of the time in big tech companies, especially if you have aged and mature project, you will have no ability to run it locally. I've heard one project which has a source code, only source code, without builds, without build artifacts, anything, just source code, pure source code. It has 0.5 terabyte of source code. Now ask yourself a question. Will you be able to run 0.5 terabyte source code on your machine? Like the building of it would take you like a day, right? Even more. So in this case, LeetCode actually really helps you because you can debug everything in your mind because this is your skill. Otherwise, apart from interview, this is not really useful. I would agree with that. But interview skill is already important enough to spend time on that. I just spent almost 2 hours on 2 problems and could solve neither. Yeah, it's kind of okay. Check my last stream. I wasn't able to solve jump game 2 for 1 hour or something. So that's kind of okay. All right, now what we're gonna do with sum. If sum is bigger than or equal to 10, what we are doing, we are incrementing carry, and we are doing sum minus equals 10, right? So if we have, for example, 16, we're gonna end up with 6, yes. And then we do dummy next node, sorry, list node with our sum. It's not dummy anymore. We need dummy to return result in the end. I think this should be the solution. Let's try it out. Let's try out with this extremely complicated example. One more thing. Yeah, I forgot this. So we have 99999 whatever, and we have 99999, and we have our dummy. All right, and we would have also our carry and our sum. Let's start our debugging. So let's start our debugging. Initially, our L1, which is this one, is 9 and 9. So if L1, we're gonna have sum equals 9. Then we're gonna have sum equals 18 after L2. Oh, you know what? We also should do this. This is what debugging makes you do. Yeah. So once we have this, we kind of process with these 9s. Okay, we move to the next. Amazing, and we added sum. Carry is 0, so it's not a problem. S more than 10, exactly, so we add in carry 1. And S minus 10, so it's going to be 8. So our result is going to be 8. Exactly 8. And yeah, that's it. We are adding it to our dummy node and moving further. Now these are our nodes. Exactly the same thing happens. Our sum 0, but carry is not. So we go, we add in these guys, it will be 18, we move further. Then we still have carry, we add in carry. So carry is going to be 1, it it will become 9, and carry becomes 0. It's more than 10, so we exactly add in carry as 1, and this should be as 9. So we are writing 9. Then we again start from 0. It will be exactly same case. It will be exactly same case for a bunch of 9s. Oh no, actually let's do that. Let's do that. At some point we're gonna have 0. Yeah, okay, let's skip it. So we're gonna have again 19, and carry is going to be added here. So I will just do this. We add in 9. Now again, same thing. I can just add 9 here. Now, interesting case. We ran out of L2, so L2 is now empty for us. L2 is empty for us, and it means what it means. It means that this guy wouldn't hit. So right now we have sum equals to 9, legit. L1 is skipped, carry is more than 1 we added, it's 10. And now more or equal 10, yes, we're adding carry 1. And we do in sum minus 10 equals 0, and 0 is what we're gonna actually add. Yeah, so to me it seems it will work. Like my debugging tells me it will work. Yeah, it will. Amazing. Done. Let's do the next one. Matrix. Oh my god, I hate. Matrix is one of the most hated problems. I don't know, problem types or patterns, I don't know. And this shitty rotate image is one of the most shittier problems or type of problems. Why? Because you either struggle a lot for a few hours, or instead of that you can just Google the specific solution that all folks that are doing image rotation ever in the production, that they just know. There is specific algorithm for that, how you can rotate image, that it's used everywhere, including Telegram and all the messengers, all the pictures and stuff. That this is how you can quickly rotate pixel by pixel. Let me tell you how it is actually done. So, let me tell you how it's actually done. I just remembered it. It's nothing. I wouldn't be able to come up on the interview with that. Let's be honest. I just cannot. But how do you do? As far as I remember, from top of my mind, you transpose matrix, and then you rotate vertically. That's it. Let me try to do that. So transpose means, let me change the color, that you are along your diagonal, you just swap the numbers from, like, using diagonal as an axis, essentially, or whatever it's called in English. So in our case, it will be this one. So we are writing 4 here. Oh, let me do it a bit thicker. It's going to be 4 and 2. It's going to be 7 and 3. It's going to be 6 and 8. And then what we are doing, as far as I remember, we vertically changing the rows, like swapping them as well. So what it will look like, I can just write it down below. It's just 7, 4, 1, because we just swapped these guys. It will be 8, 5, 2, and it will be 9, 6, 3, because all of them are swapped essentially. So checking exactly right. So this is what we should do. Unfortunately, we just, you know, you just need to know it. I just know it. I just memorized it once I saw it. You just have to know it. And this sucks if you get this problem on the interview, your interviewer is probably a dumb piece of engineer, because usually if you're not clever, you will not be able to come up with this. Like, there is no reasonable intuition for average developer that is not crazy clever that can get to this transpose and rotate. What you would be probably doing is trying to come up with some complicated indexing mass logic that you will almost for sure fail at some point. You will hit some edge case, or it run out of boundary or something, and you will not be able to solve it. And then debugging is crazy as well to maintain these pointers in your mind. This is what we're going to do. So first transposing, then rotating. Now, how do we do transposing? And this one I don't really remember, so I will need to come up with in my mind. So transposing, if we are going this is as an axis, we should start. This is our row, this is our column. So we're going row, since we have n times n matrix, we start row, and how many columns? Okay, just panels. The annoying thing is that they ask for in place. Yes. I spent a few hours this weekend enabling Alice and Bob games for. Oh my God, there are folks that are doing daily problem for the reference, so you folks understand what the guy is talking about. Yeah. Alice and Bob, I hate these two guys. I think if somebody would tell me, okay, my name is Alice and my name is Bob, I would just stop the conversation and ban these guys ever and everywhere in any channels and chats, I guess. Because this is crazy, like, yeah, this daily was, fuck it. Honestly, this was very bad daily. It's just pure math. I hate this type of problems because it doesn't actually do any good pattern for you, except that you need to come up with math for specific and very extremely unique problems. So most probably the chances that you will get a similar problem with the similar intuition that is used here is so low that it makes no real reason to solve this at all, because there is no actual broader pattern you're learning from this problem. It's just waste of time, usually. I hate this problem, and this is most of the dailies, unfortunately. So if you're preparing for interview, don't do daily LeetCode challenge ever. Don't do it. Overall, game theory problems, typical Alice and Bob, they involve interesting game theory dynamic programming type of questions, which is quite interesting. It is using dynamic programming, so it does use the pattern. So these problems I love them. They are good, and they are very unique. You should, like game theory dynamic programming and general dynamic programming, these are two completely different dynamic programming patterns, and you need to learn them separately. You cannot just reuse one of them. I participated in this, but I could only solve the first two problems in the contest. Okay, come on, it wasn't that bad. No, for me it was. Sorry, but this problem, I don't like it. And of course, I wasn't able to solve it on my own, yeah. Greedy and dynamic are similar but different. Yes. This is, by the way, is greedy. It should, yeah, greedy. Greedy is the most kind of cheeky-bricky, like, very, like, irritating and very unique problems that usually no pattern will help you with greedy. Sorry. With greedy, you just have to be clever, unfortunately. Okay, let's get back to this. So how do we actually transpose it? How do we actually transpose it? So 0, 0 should be changed with 0, 0. 1, 0 should be changed with 0, 1. And then let's say 1, 1 with 1, 1. And now 2, 0 with 0, 2. as well as 2, 1 with 1, 2. So essentially we would be rotating row and column between each other, but how do we know how many columns we should process? So definitely we should go all rows. So it should be for all rows. But how we compute the boundary for columns? Can it be just the row itself as an upper bound? Probably yes. So let's try. Yeah, and of course rows calls len matrix, because we know n times n. So for row in range rows, for column in range probably rows divided by 2, isn't it? Or no? But upper bound. So for row equal to 1, we should go 0 and 1. For row equals for 2 divided by 2 is equal 1. So we should go 0, 1. No, actually. Yeah, we can 0, 1, 2. 2 divided by 2 is equal 1. 0, 1. So it should be inclusive. Plus 1, probably. Let's check whether this logic would be working with this larger matrix. So here we should transpose I think we should touch this, this, and this. So 0, 1, 2, 3. So for 2 divided by 2 equal 1. So it should be 0, 1. So inclusive essentially. Yes. And for 3 it's going to be 3 divided by 2 is equal 1. 0, 1. No, it doesn't work. This formula doesn't work. Can we just go up to number of rows? So since this is 2, this should be 2 as well. Can we do that? Let's try this out. So if it's 0, it will be up to 0. If it's 1, upper bound can be to 1, so 0, 1, which is this one, okay. This is 2, 0, 1, 2, which is this one, okay. And 3, 0. Okay, so how we, yeah, this is wrong formula, sorry. We're gonna go up to range of R. It should be upper bound or lower bound. Oh, sorry, exclusive or inclusive. If it's 3, 0, 1, 2. If it's 2, 0, 1. No, it can be exclusive because we don't have to process the diagonal elements themselves, because it will be trivially the same. Now, what do we do is matrix row column equals, oh my god, yeah, it should be TMP. Oh my god, matrix. In Python there is better way of doing that, but I don't like it. So this should be the swapping part. And after transposing, rotate vertically, which is, we're gonna switch these two and these two. So for that, we again process every single row, but now it's row divided by 2. We are streaming close to 2 hours probably right now. Let me change it to some. Yeah. Yeah, perfect. hopefully. Okay, so now it should be rows divided by 2, essentially. So it should be 4 divided by 2 is equal to non-inclusive boundary. In range rows, for column in range rows divided by 2. What if it's 5? Just gonna check. 5 divided by 2 equals 2. Yeah, and this guy still missed. Okay, it should work. It should work. So again, TMP matrix RC matrix RC. How do we do that in this case? So this is going to be 0, 0. This can be 0, 1, 2, 3. It's going to be 0, 3. And then these are with swiping. Then we need to do that. So it should be 0, 1 swiped with 0, 2. So it should be matrix cos minus C. Is it the case? Will it work? So 4 minus 1 is 3, 3 minus 0. 3 minus 0 is equal to 0. And if it's 1, 3 minus 1 is equal to, yeah, kinda should work. Should we return anything? No, we shouldn't. I mean, according to my math in my mind, it should work. Let's just try out. Like, debugging matrix is extremely complicated and hard thing. And it's painful. It's even painful. Cognitively, I feel pain to debug this shit. Yeah, just works. Okay. True, greedy, and dynamic are similar, but okay. Greedy is like there is set optimal step you can do each time to get an answer. Dynamic is in history, bunch of sub-problems, alternative, possible paths to get an answer. Yes. You may like Sprague, greedy theorem, game theory problems, then what is this? I thought it was just typo for city Prague, whatever. Every impartial finite two-player game under normal playing convention is equivalent to a single pile of nim, whatever. Is it something from game theory math? Ah, yes. Yes, probably this is what stays under this dynamic programming game theory based thingy. Oh shit, I opened Visual Studio. I should. The TMP variable makes it not in place, right? Why? It's just value. So essentially, it's the same like you have variable a and b, and you need to swap it. How would you do it? I mean, in Python you can do it like that. So you need a to be 2 and b to be 1. So in Python you can do this, of course. But for average other languages, what you are doing is you're doing TMP equals a equals b equals TMP. This is essentially the same. So we can even test it now. Print a, b, and just you will see. So So it's 2, 1. So A is equals to 2, B equals to 1. And same thing will happen if we will just do this. Okay. So look now. Yeah, it's same thing. So it is in place, actually. We don't do anything new. Because we are kind of changing the same matrix, same memory. I thought it was an array. No. Cool. Thanks for reference for game theory. Yes, I will check later. You could avoid it by doing if R more than C. So I didn't really get what you mean. Oh, you really iterate only one part. Is it needed then? What's needed then? Sorry, I'm not sure what's needed. Yeah, I can use this Python swap, but I don't like it, to be honest. With this matrix bunch of indices, you then don't understand what's going on. Okay, let's maybe solve the last one for today. How many hours we are streaming already? I don't know. We have 10 people. Oh, it's actually great. I would expect 3 guys watching it right now. It's not cool. Then longest substring without repeating characters. Given a string S, find the length of the longest substring without duplicate characters. Okay. This is sliding window. We have well-known pattern. So, how do we do that? I just know it already, like in my intuition, once I see the problem, I already kind of have this picture in my mind. I will even show you. I already have this picture in my mind that every single time I will just start with A, B, C. Then in A, I see that I have already A, and I will do this. Then I will try this. I see I already have B, I will do this. And then I can see that C is already existing. Again, this. Okay, B is still in the window. I'm shrinking even more. Then I'm extending. Okay, B is here. So I'm shrinking even more to single B, and that's it. So this, for me, sliding window is pretty natural, pretty intuitive thing for most of the problems. So we will just code whatever I just showed you with this. This is the sliding window, so it should be pretty simple. Actually, it should be high. What the hell? Why is the acceptance rate is so low? Wait a moment. How come this acceptance rate is less than 60%? Okay, the only one thing that we should know that how do we know that we already have this element inside the window? We can use set because we can kind of keep invariant that our window should always have unique numbers, which means if we don't have map and frequency, we only can have set, right? Yes. And we will maintain set dynamically, and we will be adding the numbers dynamically as well. So let's say we have in our set ABC, we see A is in set, so we kind of removing left, and if left is A, we remove it from set, and then this is somehow how we proceed, right? Should be working actually. Should be working. Yeah, should be working. So let's name our set. There is well-known pattern. I just have it in my mind already. So we have left as our left pointer, right is our right pointer. These are inclusive pointers. So it means if I have left 0 and this one is 2, right one is 2, it means it's 0, 1, 2. This is our sliding window. Yo, what's up? Hello, hello. Sorry, I missed something. Can we suggest problems? Yeah, you can, but I cannot promise I will not stuck with them. Yeah, for sure, suggest, no problem, we can check. I actually did it once in some streams 1 year ago. What's up? All good, all good. We're finishing. This is the last problem for today. I have a question, bro. Yes. Can you advise me how to prepare for an interview BCG? What is BCG? Boston Consulting Group. Boston Consulting Group. Is it big tech or no? I don't know. What type of interviews do they have? I don't know. It depends. American Global Management Consulting Firm Fund. Okay, pretty old one. Employee. Pretty huge one. Not bad. I don't know which type of interviews do they have. You should research. If it's LeetCode system design, typical FANG, big tech style, then do LeetCode and system design. It's like very simple, right? But if it's not LeetCode system design, it can be some Linux troubleshooting. Also depends on the role, right? If you're a production engineer, you probably will have Linux troubleshooting interview. If not, then probably LeetCode system design for big tech. If not, then other type of interview that I'm aware of, or software AI engineer role. So AI engineer role. I don't know what do they ask for AI, but what I know, if you're going for AI, you're going to have specific system design, probably mostly specified on AI domain. So one type of question that you can get is design me OpenAI ChatGPT for many, many users. For LeetCode, it will be probably same algo section, and you probably might have some additional round that will check your AI skill itself. How they do that, I don't know. I never worked as AI engineer anywhere, and my AI understanding is pretty limited, I would say. I cannot help with that. So AI part you should cover yourself. Also talk to recruiter. They should tell you how to prepare to interview. Recruiters are always doing that. They should send you what will be the interview rounds, what type of interviews you're going to have on these rounds, and how to prepare. They will even send you preparation for that. At least all big tech companies are doing that. Just follow it. Okay, back to our sliding window. So how do we do it? We just checking while as right in set. What we are doing, we are removing set. Oh, I forgot how do we remove items from set. So I know that adding is this one, but is it remove or? Yes, it's remove. Amazing. So we are removing whatever we have on the left. Length of longest substring without duplicate characters. Okay, amazing. We are removing whatever is on the left and adding left. And then we are adding right. And then we are also checking our answer or updating our answer. Seems like that should be the answer. Let's check it. So we're starting with right equals 0. Right is not in S string, so sorry, not in S. Oh my god, what did I check? It should be in. Let's name it map, whatever. So, and let's call this map as well. But it's essentially set, or hash set. So if right is in map, it's not. Then we are adding right. Well, not right. Again, we just spotted the bug. We're adding string under index right, which is a, or character. We move our right cursor, right minus left, 1 minus 0 plus 1. No, right will be 0. 0 minus 0 plus 1 is 1. Essentially, it should be 1. Then we're moving our right cursor. We see B. B is not in the map. We're adding B. We're extending 2. And this is going to be 2 as well. Same for C. Extending this one. Yes. Now we are encountering A again. So A does exist in our map. So we remove whatever is in left, which is A. And we're increasing our left. Now we can add A. And our answer is going to be 3A again. Then the same happens with B. So we see B, we remove B. We increase our left by 1. Then we increase our right by 1. And we're adding B. Then same thing happens with C. We just check that it works. Then A, B, C, B. This is interesting case. So now we have B. This should be 6. Oh my God. Right, 6. Left is 3. Exactly. A, B, C, and 6 is the next one. Yes. So we have B, and while B is in the set, we're removing left. So we removed A, make it 4. Still in the set, we remove B, make it 5. Make it 5. And then we can add B. Yeah, it kind of should work. To me, it seems, at least according to my debugging skills. Yeah, it kind of worked. Thank you so much. No worries, bro. No worries. Yeah, ask anything. The candidate arrays can't be more than 26 elements, which makes brute force possible too. In this case, you mean? I'm not quite sure about this. Or you mean previous rotate image problem, or what we had previously? Yes, I don't know. All right, I still don't understand how come acceptance rate can be 39% for this simple problem. I mean, if this happens in daily LeetCode challenge, 30 minutes after this problem appears, it will be 70% of acceptance rate. Like, I don't understand why this problem has so low acceptance rate. It should be like 70 or 80 even. Because this is very default question, very default question. If you get this on interview, this is like, you got so lucky with that. Okay, I don't know how many problems we solved today. Let me count. So we revised the Jam Game tool. We don't count this. 1, 2, 3, 4, 5 problems, which is not bad for our session. Everyone, please message me to my email or whenever for collaboration. Yeah, good water, by the way. Anyway, guys, I think we are going to finish up and wrap this session up, essentially. So thanks you all for being with me in this stream. It was extremely pleasant. I got my confidence back. Today we performed much better than yesterday, which I'm happy about. We have 12 viewers overall, which I'm very happy about. Thank you so much for being with me. Don't forget to subscribe to my Telegram channel because all the updates are there, or at least Instagram channel. All the updates are here, all the updates about my life, fun, different kernel networks, system design problems, and discussions are there. Don't forget to do that, and yeah, see you somewhere next days. We're gonna stream for probably a few weeks, starting from today or from yesterday. So there will be more sessions. I hope we can solve these top 100 like questions at some point. I hope so. I hope so. So yes, that will be it. Thank you so much, and see you later. Bye bye.